Welcome to week 5 of our C++ track. This week we'll be focusing on handling functions and other callable objects in C++. We'll start that conversation in this video by taking a look at operator overloading. While working on some of the projects so far, you may have noticed that there are objects in some libraries that understand how they should behave when you use arithmetic operators with them. For example, we've been using the eigen library for linear algebra. We used the matrix class from this library, and when we wanted to multiply two matrices together, we just used the normal multiplication operator. But how did the program know what it means to multiply two matrix objects? Well, in C++, we can overload nearly any operator to give specific definitions for our objects. This lets us customize operators to do meaningful things. Under the hood, operators are just functions with special names. An operator function name starts with the keyword operator and then has the operator symbol. To overload the addition operator, we'd create a function with the name operator plus. The parameters of the function are the operands of the operator. The value our operator returns becomes the value that the operator expression will evaluate to when it's used. There are two places we can declare overloaded operators that have slightly different meanings: inside of a class and outside of a class. When we declare an operator overload as a freestanding function, all of the operands are passed in as parameters. For operators that use two operands, the first parameter is the left operand and the second is the right operand. When we declare an operator overload inside of a class, the class's object is always our first or left operand. Declaring operators inside of a class is sometimes required, either because the language requires it or because the operator's implementation needs access to protected or private class members. Let's take a look at an example that uses operator overloading in a couple of ways. In this example, I've declared a new struct point that has two members, x and y. This can represent a point in 2D space. Just with those two members declared, we can create 2 points and use aggregate initialization to set them to the coordinates 0, 0 and 1, 1. Now let's say we want to find the midpoint between those 2 points. Well, it'd be nice if we could just write a plus b divided by 2, the easy, simple equation for finding the midpoint. Well, we can, and that's because we've provided overloads for the plus and division operators. Here's the plus operator. Because it's declared inside of the struct, the current object will be the left-hand operator, and this other object that's coming in from the parameters will be the right-hand side operator. To get our result, we just add our 2 fields and return it. So whenever we add one point to another point object, we get back a point object. The division operator is similar, only this time we're dividing by a single double, a scalar value. Similar structure where we apply the math to each of the individual members and then return the result. So this tells us that when we divide a point by a double, we will get a new point. With these two operators combined, we're able to execute this line of code. Each operator calls our overloaded version of the function. Now we've also declared an operator outside of our class. In this case, it's the stream insertion operator. This is the operator that's used to print things out through the iostream cout object that we've been using. You'll often see an operator like this one defined for pretty much any custom object either in your project or from a library, because it enables us to write a line like this, where we use cout and we just directly print out the point object itself. Looking at the operator overload, we can see that the left operand of the stream insertion operator is expected to be a stream, and we're giving it cout here. And then the right-hand operand is meant to be a point, and we're giving it mid. In the definition of this function, we're just printing out the x and y variables of our point in a human-readable form. And then to enable us to chain multiple insertion operators together, this operator is meant to return a reference to the stream that it got in. And this is why we can say cout insert mid, and then take the result from that, which will again be cout, and insert the new line character. So in this example, we've got 3 examples of different kinds of operators. An operator that defines a math operation between 2 objects of the same type. An operator that defines an operation between our object and some other type, in this case double. And then an operator defined outside of our class that happens to use our class as one of its operand types. Operator overloading is an important part of making our objects convenient and intuitive to use. There are rules and conventions for overloading operators in practice that we haven't covered here, but you can read more about those on the operator overloading page of cppreference.com.